construction. Not today, I'll tell you later. So today, and this is a joint class, we'll start for vector calculus. As you know, in real calculus, uh, there is a function, definition of function. So here from your chapter 8, it starts from differentiation, but before that you have to define a function. A function, um, for a function we must have one variable which f, say f is a function of x. If for any value of x on that region we can get a value of f, then we say that f is a function. Similarly, that is a scalar function. So for vector function, if there is a vector, say vector, depending on some r. So for each and every value of r, if there is a value of that vector, we say that that is a vector function. So that is the definition. This is the elementary part. Now we come to the chapter 8. Uh, all of you please open that chapter from Grewal book, chapter 8, vector calculus. Okay. Here are some topics which are not directly included in your syllabus. I will tell that. But first of all, we start from article number 8.1. That is differentiation of vectors. Here, a vector r is a function of scalar variable t. So r is equal to written as ft. See the capital letters that denotes vector. Therefore, ft is a vector function which varies continuously as scalar variable t changes. Now, what will be the derivative of that function? Df dt. By definition, it is delta t tending to 0, f t plus del t minus f t, that is the increment of f t divided by del t. So del t tends to 0, and we denote that as df dt, or as the usual f dash t or dr dt. Therefore, this is the derivative of the vector f. Now, if there are more vectors, say f, g, h are vectors, and small phi, that is a scalar quantity. Now, that property of linearity for derivatives, that is also applicable here for your vector function. Therefore, here you see two general rules for differentiation. Number one is d dt of f plus g minus h. That means df dt plus dg dt minus dh dt. This is called linearity property. Now see number two, if a vector is multiplied by a scalar, and if we want to find its derivative with respect to dt, with respect to t, then d dt of f and phi will be f d phi dt, and d phi dt is a scalar quantity since phi is a scalar, and df dt multiplied by phi. Now in this relation you see there is no sign of dot and cross. Why? Phi is a scalar quantity, we can always multiply phi to a vector function, there is no need of sign. Therefore d phi dt is also a scalar, therefore f multiplied by a scalar quantity. Similarly, phi multiplied df dt multiplied by phi, there is no need of sign. But in number 3, you see d dt of f dot g. Can you follow? Have you opened?
Ma'am, it would be better if you present your screen or something.
Jadip?
Yes, ma'am. Yes, ma'am.
Jadip shared that chapter, first page.
আচ্ছা আমি শেয়ার করে দিচ্ছি।
হুম, আর একটু বড় করো, আমার দেখতে অসুবিধে হচ্ছে। হ্যাঁ, so is it visible to everybody?
Yes, ma'am.
So see, dfdt is the differentiation of the vector f. And now general properties or general rules. As I have said, ddt of f plus g minus h, ddt of f of phi. Now we were discussing number 3 property, ddt of f dot g. This is the product of two vectors, dot product. Therefore, that will be f dot dg dt plus df dt dot of g. Similarly, vector product, that is f cross g, ddt of f cross g is f cross dg dt plus df dt cross of g. And then scalar triple product, etc. That is scalar triple product is in vector algebra. Therefore, I'll not discuss that one, since vector algebra will be taken by someone else, by some other teacher. Therefore, this is the triple product of FGH. Therefore, ddt of FGH, and these are 4 and 5. These are scalar triple and vector triple product, and derivative of that. Now, one proof is given for 4, f cross g. ddt means f cross g. ddt means the increment divided by delta. Therefore, f cross g is a vector. Its increment is given f plus delta f cross of g plus delta g minus of f cross g divided by delta t. And then delta t makes delta t tending to 0. And thus the result comes. Now you see that one observation is there. It is a small, it may be a small question. See, if ft has a constant magnitude, that means is modulus is constant, then show that f dot df dt is equal to 0. What is given? The magnitude is constant. That means come to the page number 316. Yes. Hmm. So ft dot of ft, that is the modulus square. Therefore, modulus of ft whole square is equal to, since modulus is constant, therefore that is equal to constant. Now we have taken dot product from both sides. What will be? See the result for a dot b. Here a dot a, therefore 2 times of f dot df dt, that will be 0. That is f dot df dt is equal to 0. Is that clear? We have taken ddt of both sides. Right side will be 0, since the right side is constant, and left side ddt of f dot f. What will be the result? F dot df dt plus df dt dot of f, by using the first result, first rule. Since a dot b is equal to b dot a, therefore this will be f dot df dt, that is equal to 0. Hence proved. Now observation 2. This is also a small question. If ft has constant direction, that means fixed direction, then f cross df dt is equal to 0. ft is said to have constant direction, not the constant magnitude. Magnitude may be anything, but the direction is constant. Now,
So, ma'am, some of us are trying to join. Would you please admit them?
uh, yes, it has not exceeded the permitted limit. Tell them. And Joydeep will accept that
Jolly, please
request.
admit them.
Okay. Can you start again?
Yes, ma'am.
Mm. The second observation is if ft এই একটু হেজি আসছে রে, একটু make it clear জয়দীপ. হ্যাঁ. See observation 2, ft has constant direction, then prove that f cross df dt is equal to 0. Now let g be a unit vector. That means it has magnitude unit in the direction of ft. Then we can write ft is equal to the magnitude of ft is small ft and direction is given by gt. Since its magnitude is 1, it gives only the direction. Therefore, ft is can be written as small ft capital GT, where small ft is the magnitude of ft. Now df dt is equal to, since ft is the magnitude, this is a scalar quantity. Therefore, by the product derivative, we have f dg dt plus df dt g. Okay. Now we have taken cross product a, cross product to both sides. Then left hand side becomes f cross df dt capital, that is equal to f is equal to, small f and capital G cross within the bracket the amount f dg dt plus df dt g. Now we have to find the cross product within the bracket. The cross product is done only with vector functions. Here dg dt is a vector function and g is a vector function. Therefore, the first term will be f square g cross dg dt. The second term will be plus f df dt, that is a scalar quantity g cross g. G cross g is equal to 0. Therefore, f square g cross dg dt. Now, since g is constant unit vector, its value is unit. Therefore, dg dt is equal to 0. Therefore, g cross dg dt is equal to 0. Hence, the observation 2, f cross df dt is equal to 0. Now, these are the examples. See 8.1 example. Here functions are given a, b. You have to find ddt of a dot b, ddt of a cross b. Simple thing. First, you can calculate a dot b, then ddt, or you can use the properties. Ddt of a dot b is dAdt dot of b plus b a dot of ddt, যেটা সুবিধা হয় সেটাই করতে পারো. First you can calculate a dot b and then find ddt. Similarly, you can find first a cross b and then ddt, or else you can use the formula for ddt of a dot b, ddt of a cross b. Now, curves in space, that is not explicitly written in your syllabus. Let me know whether it is included in that. You just come to you just come to derivatives. That means gradient and divergence. Jaideep, Jaideep.
Yes, ma'am.
After that, you can share my note which I have sent it today,
Okay, ma'am. Sure.
because this is simpler. Now we'll discuss the differentiation of scalar functions and vector functions.
Ma'am, can you please confirm this note or not?
uh, I cannot see, share it. 5.2, these are the uh, no, the next part. That is the first part and this is the second part.
This one.
Yes, yes. Differentiation of scalar and yes, differentiation of scalar and vector functions. Now, what is gradient? Gradient is yes, yes. Hmm. এটা আবার বেঁকে গেছে কেন? নেক্সট পেজে যাও 5.39 5.4 এটাকে একটু রোটেট করে ফেলো তো, রোটেট করা যাবে? দেখো আচ্ছা দেখি তো তোমাদের, তুমি যেটা পাঠিয়েছো সেটাতে কি আছে।
পেজটা উল্টো আসছে না।
ঠিক আছে, ফরগেট দ্যাট। শোনো, তোমার ওই গ্রেওয়ালি করো, পেজ নাম্বার 322। এটা ফরগেট দ্যাট, এটা উল্টো আসছে, অসুবিধা হচ্ছে, পরে আমি ঠিক করে পাঠাবো। গ্রেওয়াল পেজ নাম্বার 322, আর্টিকেল 8.4, আর্টিকেল 8.4। ইয়েস, স্কেলার অ্যান্ড ভেক্টর পয়েন্ট ফাংশন। তোমরা আমি যেটা যেটা পড়াচ্ছি সেটা জাস্ট মার্ক করে রাখো। ইফ এনিথিং ইজ লেফট আই উইল ডিসকাস at the end of the session, not this session, at the end of our semester classes. So it is a scalar and vector point function. What is point function? Scalar point function. If for any value of a point r, there is a value of a scalar function in that region, that is called scalar point function. Similarly, to each point of a region, if there exists a vector, definite vector, then we say that that is a vector function, and the region is called the vector field, and the region for scalar is called scalar field. Now differentiation, say f(x,y,z) be a vector point function, then the differentiation is given by this df dt. Df dt is del f del x dx dt plus del f del y. F is a function of x, y, z. X, y, z are scalar quantities. Therefore, df dt can be written like this. Df dt is del f del x dx dt plus del f del y dy dt plus del f del z dz dt. And the total differential df can be written by this: del f del x into dx, del f del y dy, etc. Now, there is an operator, differential operator, which is known as del, vector operator del. What is that? I del del x plus j del del y plus k del del z, that is called del, or the vector operator del. Therefore, this is a vector quantity since I, j, k, these are all identity vectors along x direction, unit vector along x direction, y direction and z direction, and therefore I del del x plus j del del y plus k del del z, this is called the vector operator del. Now Say, this is a differential operator. This can be applied to both scalar function and also vector function. Now the next 8.5 article, del applied to a scalar function. When the operator del is applied to a scalar function, it is called gradient of that function. And we write it as grad f or del f. So see, um, then gradient of f is equal to I del x plus j del y plus k del z is the grad, or is the del operator operating on f. Therefore I del x plus j del y plus k del z, that is called grad f. Now there is a geometrical interpretation, please go through that. Finally, grad f is a vector normal to the surface f is equal to constant. Now come to a directional derivative. Directional derivative of any function f in the direction of any vector n is the result part of del f in that direction. That means del f dot of n dash, that is called the directional derivative. Now come to the example. There are plenty of worked out examples. Just go through those. Then you can calculate any problem. You can solve any problem. Uh, you have to prove that delta r to the power n is n r to the power minus 2 capital R, where capital R is the position vector. This is called position vector, which is R is equal to Ix plus Jy plus Kz. How we can find? We know that R square is equal to x square plus y square plus z square. Then R is equal to x square plus y square plus z square to the power half. Come to the example 8.9. Yes, 8.9. 8.9. You have to find del of r to the power n. That means grad r to the power n. We know r square is equal to x square plus y square plus z square. Then r is equal to x square plus y square plus z square to the power half. Therefore, r to the power n will be x square plus y square plus z square to the power n by 2. Then you have to calculate, yes, you have to calculate that grad of u that they have done. Del r to the power n is equal to this, and have substituted ix plus iy plus iz as capital R or the position vector. Similarly, in 8.10 also, find u. If this is del u is equal to this, you have to find u. That is simple. Del u, the right hand side they have calculated, and del u is the left hand side, that is I del u del x plus j del u del y plus k del u del z, and equating both, they have got del u del x, del u del y and del u del z, and integrating they have got u. This is simple. Now come, these are all worked out examples, just go through that so that you can solve any problem. Now come to 8.6, del applied to vector point function. 8.6, these all these problems are del applied to scalar functions. Now 8.6 gives del applied to vector point functions. These are all worked out examples. Yes, 8.6. Del applied to vector point function. Del is a differential operator. We have seen how this differential operator operates on scalar function. Now we will see how this operator operates on vector point function. Now the divergence, there can be two types of application, because del is a vector quantity, and if it is applied to vector quantity there must be some dot product or maybe cross product. Dot product is called the divergence and cross product is called the curl. Therefore divergence f is equal to del dot f. Because del has to be applied on f, how it can be applied? Just product without no sign doesn't mean anything for vector quantities. Therefore del dot f, that is called a divergence of f, which is del dot f, just you can find f is equal to if plus phi j plus psi k. These are the value of f, and then divergence f is write del and write f, and then calculate. You get del f del x plus del phi del y plus del psi del z. Is that clear, or I will tell it again? I will explain it again. Say f can be written like this: I of small f plus j of small phi plus k of small psi, where f, phi, psi, these are the components along x-axis, y-axis and z-axis. Therefore f is resolved like this. Then divergence f means del dot of f. What is del? Del is I del del x plus j del del y plus k del del z. Dot of f, write the value of f I plus phi j, or if plus j phi plus k psi. Now calculate the dot products. Only I dot I will give non-zero, because if we get dot product I dot j, that will be 0. I dot k will be 0. Similarly j dot I, j dot k will be 0. K dot I, k dot j will be 0. Therefore only the non-zero quantity will be I dot I, right? Because f is a scalar quantity, take out f, then we have I dot I is equal to 1. Therefore del f del x. Similarly j dot j, that is del phi del y, plus k dot k is 1, that gives del psi del z. Therefore divergence of f, which is del dot f, is equal to del phi del x plus del phi del y plus del psi del z. Therefore you see that the dot product of two vectors, we know it is always a scalar quantity. Therefore divergence f is a scalar quantity. Now what is curl? Curl is called the application of del on some vector function. Here curl f is equal to del cross of f. Del is a vector quantity, f is a vector quantity. We have seen del dot f. Now another product is del cross of f. Now del cross f, how it can be calculated? We have resolved f is equal to if plus j phi plus psi, k psi. Therefore curl is del cross of f. That means del is I del del x plus j del del y plus k del del z, cross of a phi plus phi j plus psi k. And cross product means the determinant I j k. The first vector components are del del x, del del y, del del z, and the second vector components are f, phi, psi. Therefore expanding this or simplifying this determinant, it gives I of del psi del y minus del phi del z plus etc. Therefore you see that there are I, j, k, which are vector quantities. Therefore these are vectors along x-axis, y-axis, z-axis, unit vectors. Therefore curl of f, as we know del cross of f, we know that cross product will be a vector. You see that the right hand side is a vector quantity. Therefore curl of f is equal to f cross of del cross of f. Now see the example. These are the main differentiation for vector and scalar quantities. When del is operated on scalar quantity, that is called gradient. When del is operated on vector quantity, one is called divergence, that is del dot of f is divergence, and curl is del cross of f, that is called curl of f. Therefore these are the main three parts of differentiation of vectors and scalars quantities. Now see the example here. The function is given as r is equal to xi plus yj plus zk. This is called the position vector of a point xyz. If a point xyz is given, its vector form is r, that is ix plus jy plus kz. Now you have to find del dot r, that means divergence of r, and you have to find curl of r. What is del dot r? Del dot r is, by formula we know that del r del x plus del r del y plus del r del z. I mean, you have to write with the components, and the components of r are x, y and z respectively. Therefore del f del x is 1, del y 1, del z is 1, therefore that is equal to 3. Therefore divergence of r is equal to 3. Similarly curl of r, you just write r, the components x y z, and del components are del x, del y, del z, and write the formula, or expand this determinant, you get curl of r is equal to 0. Therefore, divergence of position vector of a point xyz is always 3, equal to 3, and curl of r is equal to 0. Similarly, see uh, the next value, next problem, example 8.19. Yes. Here f is given as, see, this is a complicated function. F is given as gradient of x cube or square. Jaideep, is it square or cube? That is very small, I cannot. X cube, right?
Ma'am, cube.
Cube, x cube plus y cube plus z cube minus 3xyz. This is the function. Now gradient of u, you have to calculate gradient of u so that you can get the value of f. What is gradient u? Gradient u is gradient of x cube plus y cube plus z cube minus 3xyz. That means we know that gradient u is equal to I del u del x plus j del u del y plus k del u del z. We know that. Then we differentiate the function, scalar function u, with respect to x, with respect to y, with respect to z. All are partial differentiations. Then we get, if we differentiate u with respect to x partially, we get 3x square minus 3yz. Therefore, I of del u del x is 3x square minus 3yz. Similarly, del u del y, keeping x and z constant, partial differentiation. Therefore, that gives 3y square minus 3xz. Therefore, j of that, and k of del u del z. That means we differentiate u with respect to z, keeping x and y constant. Then it gives 3z square minus 3xy. Therefore, k into 3z square minus 3xy. Is that clear? Jaideep, is that clear? Now I will ask everybody, is that clear up to this point? Gradient of u. Shramana,
Yes, ma'am, it's clear.
Shramana or Shrabona? What is your name? I have
Ma'am, Slobona.
Shrabona. Oh, I see. I have named it as Shramona. Okay, Shrabona. Shobana, is that clear till del u, gradient
Yes,
u?
ma'am. Yes,
So
ma'am.
gradient u defines the function f, vector function. Then from that f you have to find divergence f. What is divergence f? Divergence f is del dot of f. You can write del dot f and then calculate, or you can use the formula for divergence, which is del f del x plus del f del y plus del f del z. Therefore, this is divergence f, and curl f we know ijk del del x del del y del del z, and the components of f along x axis, y axis, and z axis, and this gives the result. Therefore, this is a complex problem. They have not given the function value. They have given the function as gradient of that. That means you have to calculate in three steps. One step is you find gradient. That means operation of del on scalar function, that gives the vector 1 vector function. Then you have to calculate divergence f, that means del dot f, and then again curl f, that is del cross of f. Therefore there are three steps. Now physical interpretation you can go in Jaydeep এরপরে that is a flow of fluid, এটা তোমরা দেখতেও পারো নাও দেখতে পারো, divergence means flow. এই এগিয়ে যাও, এইগুলো দরকার নেই, এগুলো সব অ্যাপ্লিকেশন টু ফ্লুইড মেকানিক্স। আচ্ছা, হ্যাঁ, এরপরে যেটা আসছে 8.8, del applied twice to point functions. একবার অ্যাপ্লাই করলে আমরা জানি if we apply once on scalar function that gives gradient. If we apply del once to a vector function that gives divergence and curl. Now these are the formula, five properties or five formula which gives del applied twice to point function. Now divergence grad phi, grad f. F is a scalar quantity, grad f is a vector quantity, and divergence of grad f. What will be the formula? Divergence means del dot of del f. That is divergence grad f. That is equal to del square of f. Take a pen and paper. We just see what is divergence grad f formula. How it comes, del square f. Just one by one from the right hand side. F is a scalar quantity, gradient f is a vector quantity, that means del f, and divergence means del dot. Therefore del dot del f, that is equal to del square f. Therefore if del is applied twice, then first formula gives del square f. Second formula, curl grad f. Grad f means del f, curl means cross, del cross del f, that is equal to 0. You can easily calculate that. First they have given the results. Divergence curl f, right, start from the right hand side. Curl f means del cross f, and divergence means del dot. Therefore del dot del cross f, that is equal to 0. Now curl f. What is curl f? Curl f is equal to del cross f, and again curl means del cross, that is del cross f, that is equal to gradient divergence f. That means del dot f, del operating on del dot f minus of del square f, and divergence gradient divergence f. Gradient divergence f means start from the right hand side. Divergence f means del dot f, and gradient means del dot f is a scalar quantity.
Del dot f is a scalar quantity.
Mm, del dot f. Hey,
Del
Saurabh.
dot f. Hey, Shobha.
Okay. Del dot f is divergence f, and gradient means del of del dot f, that is equal to curl f plus del square f. Now all these proofs are very important, just mark it. These are very important results, frequently comes in your semester problems, semester exams. Therefore do not skip these results. Proof first, del dot del f, that is del dot del f means I df dx plus j df del f del y plus k del f del z, and this is proved. This operator del square operator is called Laplacian operator. Del square is called Laplacian operator. Now the second proof. Second proof is curl of grad f. Divergence of grad f is equal to this. Now the second is curl grad f. Grad f means del f, curl means del cross del f. See, they have first written del f or gradient f, that is I del f del x plus j del f del y plus k del f del z. And product is del cross. Okay. Now del within the bracket, that quantity is a vector quantity. Then vector quantity and del is also a vector quantity, and find the cross product. Cross product is ijk, and within bracket, that is del f del x, curl gradient components, that is del components, these are del x del y del z, and then the next vector component are del f del x del y del f del z. Therefore simplifying this gives this is equal to 0. See, each and every quantity is 0, therefore that is a 0. 0 means, what does it mean? 0, is that a scalar quantity or is that a vector quantity? Tell me. Shobana? Number 2. The right hand side is 0. What is the left hand side? Is that a vector quantity or is that a scalar quantity? Jaideep?
Vector, ma'am.
Yes, vector. Right. Because gradient f is a vector, del is a vector, and their cross product is also a vector. Therefore, left hand side is a vector, right hand side 0 means that is a vector, null vector. That means all the components are 0. That is a null vector. Now come to 3. Number 3. Jaydeep, ektukani scroll up karo. Yes, number 3. See that del dot curl f. That means divergence curl f. Divergence del formulata লিখেছে, then dot, then curl, and they have calculated this one. This is very simple thing. Similarly 4 and 5 also, you just go through it, take your pen and paper and calculate it yourself, so that it is it becomes very simple for you. Otherwise it is very simple result, but whenever you try to calculate it, if it is in semester, it becomes very difficult. Therefore calculate yourself and you will find that the results are simple. Now come to the next topic. These are, I am again telling you, these 5 formula are very important formula. It is frequently used afterwards in practical problems, in physical problems. Therefore, do not skip these results. These results always, sometimes you can find it at your semester semester exam also, therefore do not skip. এই তো করেই দেওয়া আছে, it are all done here, therefore just calculate yourself, solve yourself, so that this is sent to you. Now come to 8.9. These are the 8.9. 8.9, del apply to the products of point functions. We know that if two functions are scalar functions f and g, their product is fg. Then gradient of fg is f gradient g plus g gradient f. Similarly, for second one is f is a small f, which is scalar quantity, and g is the vector quantity, vector function. Vector function is multiplied by a scalar. Then divergence fg, divergence of fg. এখানে দেখো দ্যাট ইজ যেখানে লিখেছে না, ওখানে ডেল ডট হবে, there is a printing mistake. Number 2, 8.9, number 2, divergence of fg means del dot of fg, otherwise it doesn't have any meaning. F multiplied by capital G, that is a vector quantity, and del cannot be applied, gradient of vector quantity cannot be obtained. Divergence means del dot, therefore there is a printing mistake, just note that this will be del dot of fg. Then del dot of fg means gradient f dot of g plus f del dot g. Similarly, curl of fg. Similarly, 4, 1, 2, 3, 4, 5, 6. These are the 6 results. These are also important results. These are just calculations. These are just once you know what is grad, what is divergence, what is curl, you can calculate any type of combination. This is another combination applied to some functions, maybe a scalar function, maybe vector function. Therefore, these are all given. You calculate yourself, you find yourself, you solve yourself, so that these results, you can calculate these results. These are all important combinations of gradient, divergence and curl. নিচে যাও, আরো এরপর স্ক্রল আপ করো তো। These are all given. Now see example. Yes, 8.22 example. Del 2 r to the power n. This is Laplacian operator del 2, and small r is a scalar quantity. Therefore, del 2 is r to the power n. What is r to the power n? You can calculate like this, or you can find r to the power n is as x square plus y square plus z square to the power n by 2, and then you apply del 2 del x2, you will get the same results. Or like this, for example, del r to the power n. R to the power n is a scalar quantity. Del operated on scalar quantity is a vector quantity. Therefore, I of del x, that means n r to the power n minus 1, and capital R by R, that gives the direction, that is a unit vector, say I or j or k. Therefore, del dot of this is equal to this, and they have calculated this. Otherwise, you can find, see, r to the power n del x2 del r to the power n del y2, otherwise যেভাবে দেওয়া আছে সেটাও করতে পারো. Therefore, this is del 2 r to the power n del x2, del 2 r to the power n del y2 plus del 2 r to the power n del z2. I think the second version is very simple. Second version you can opt for the second version. 1 minute. Hmm. Similarly, see 8.23. Example 8.23. U and V, these are scalar functions, and f is a vector function, show that f dot curl f is equal to 0. Given that f is equal to 1 by u gradient of v. Therefore, curl f, they have calculated curl f, and then f dot curl f they have calculated. আজকে এই পর্যন্তই থাক, অনেক হয়েছে পড়া, because that is a new concept. Therefore, I think I should stop here. And the gist is, first we have defined what is scalar function, what is vector function. Then we have found the differentiation of a vector function. Similar to scalar function, only thing is that when we derive vector function, this again becomes a vector function. Then we have defined a differential operator, which is a vector quantity, which is known as del, which is I del del x plus j del del y plus k del del z. That is a vector differential operator. Now, this vector differential operator can operate on scalar function, also can operate on vector function. While it is operating on scalar function, it gives del f, that is I del f del x plus j del f del y plus k del f del z, that becomes a vector function. Therefore, when operating on some scalar function, del gives a vector function which is defined as the gradient of f. Now, del can be applied to vector function also. There are two types of application. One is dot application, another is cross application. If capital F is a vector function, then del dot F is called divergence of F, which is I del del x plus j del del y plus k del del z dot of F. If we resolve F as Fi plus phi j plus psi k, then this gives divergence of F, that is del dot F, which is a scalar quantity, del f del x plus del phi del y plus del psi del z. Therefore, del dot F is a scalar quantity, which is called divergence of F. Now, if del is operated on vector quantity by curl product, cross product, then we say that that is a curl F. What is curl F? And I del del x plus j del del y plus k del del z cross of F, that is called curl of F, and that is a vector quantity. And these are the main differentiation of scalar function and vector function, and all types of combinations are like that. The properties in the properties, all types of combinations are given. And then we have discussed the double application of del also, and those are given in the formula. Therefore, these are the differentiation of scalar function, vector function, and etc. And their The problems are there are worked out problems. You just go through that. If there is any difficulty in the worked out problems, just tell me in the next class so that we can discuss. And if all the worked out problems are done by you, there will be no difficulty in solving the examples also. Therefore, first of all, go through the worked out problems with Dale, with divergence, with curl, with gradient. Therefore, this is the gist of today's class, but there are several problems that you have to do yourself. Just go through the properties, go through the formula, and then come to the example. Is there any point you want to know? Vishal, Rahul, Partho, Shobhik, is there any point you want to discuss today? Jaideep?
No, ma'am.
Then next day I'll ask from divergence, curl, and gradient. Okay, and then we will proceed. Shravana,
No problem, ma'am.
Shravana, just make the um, attendance sheet of today's class from your section, and Jaideep, make the attendance sheet of the students from your class. Okay,
Okay, ma'am.
and
Okay, ma'am.
send it to me today at night or tomorrow in the morning. Okay.
Okay, ma'am.
Okay. Okay. So there will be another class on Monday, next Monday. Joint class. That will also be a joint class. Okay.
Okay, ma'am.
আচ্ছা, সো এই পর্যন্ত থাক আজকে জয়দীপ।
হ্যাঁ ম্যাম।
হ্যাঁ ঠিক আছে, অনেক পড়া হয়েছে, এগুলো সমস্ত ক্যালকুলেট করো, এগুলো সব নিজে নিজে করো, ডু ইট ইউর সেলফ অ্যান্ড দেন উইল ডিসকাস নেক্সট ডে। ঠিক আছে,
হ্যাঁ ম্যাম।
Thank you so much, ma'am.
থ্যাংক ইউ ম্যাম।
থ্যাংক ইউ অল, বি সেফ।
Absolutely, ma'am.
এই তোমরা সবাই নিয়েছো ভ্যাকসিন? হ্যাভ ইউ
হ্যাঁ
গট?
ম্যাম, সবাই
ম্যাম
সবাই
একটা
নিয়েছে।
ডোজ হয়েছে,
ফার্স্ট
দুটো
ডোজ
ডোজ
নেওয়া
হয়নি।
হয়েছে ব্যাস।
হ্যাঁ একটা ডোজ হয়েছে, একটা হলেই সেকেন্ড ডোজটা হবে আফটার 80 days or 90 days। কেননা বলছে তো আফটার পূজা ভেকেশন, দ্যাট মিনস বাই দ্য এন্ড অফ অক্টোবর ইউনিভার্সিটি যদি খোলে হোপফুলি, তাহলে তাহলে তো যারা যারা নাওনি তারা নিয়ে নাও, অ্যাটলিস্ট ওয়ান ভ্যাকসিনেশন তো নাও। ইউনিভার্সিটি থেকেও তো তোমাদের নাম কালেক্ট করছে, সেখানে নাম দিয়ে দাও যারা নাও।
হ্যাঁ ম্যাম, দিয়ে দেবো
হ্যাঁ
ম্যাম।
হ্যাঁ ঠিক
ম্যাম
আছে।
কলেজ খুলছে না, বোর হচ্ছি ম্যাম ঘরে।
হ্যাঁ সে তো বটে, আর এরকম ভাবে কি ম্যাথস করা যায় রে?
না
হ্যাঁ
ম্যাম, এটা
সেটাই
তো
তো।
ঠিক ম্যাম।
ম্যাথস, তারপর তোমাদের ড্রয়িং, তারপর তোমাদের ল্যাব, এগুলো কি এইভাবে করা যায়? ফার্স্ট ইয়ার তো ঠিক আছে কোনো রকম ভাবে চললো, সেকেন্ড ইয়ার কি করে
সেটাই তো
হবে?
ম্যাম।
তোমাদের ল্যাবটাই তো মেইন না?
হচ্ছে না
ল্যাব
ম্যাম,
ক্লাস
একদম
তো
হচ্ছে
হয়ই
না।
না আমাদের।
ল্যাব ক্লাস কি
ম্যাম
করে? ল্যাব মানে তো হাতে করতে হবে, তো সেটা কি অনলাইন হয় নাকি?
ম্যাম
আর ম্যাথস
ম্যাম
ক্লাস?
লাইক, হ্যালো ম্যাম।
হ্যাঁ বলো।
ম্যাম যে পড়ানোর টাইমে স্টাইলাস ইউজ করবেন, তাহলে পরে লাইক বুঝতে সুবিধা হয়।
কি করবো?
ম্যাম পেন ট্যাব মোড
রাইটিং
যদি
প্যাড।
আপনি ইউজ করেন। হ্যাঁ।
হ্যাঁ হ্যাঁ।
আর টেক স্যাভি, আমি এরকম ভাবেই ক্লাস করছি। তোমরা করে যদি কোনো প্রবলেম হয়, আই উইল টেক অ্যাজ মাচ অ্যাজ ইউ নো, অ্যাজ ইউ ওয়ান্ট, অ্যাজ মাচ ক্লাসেস। আমি অন্য কিছু করতে পারবো না, মানে আমার অত অত টেক স্যাভি নই, আর আমার ল্যাপটপ ভীষণই মানে খারাপ অবস্থা চলছে। দেখো আগে করো, বইয়ের মধ্যে ওয়ার্ক আউট করে দেওয়া আছে, তারপরে আমরা ডিসকাস করব। আর তারপরে অক্টোবরে যদি খুলে যায় তাহলে তো ক্লাস হতেই পারবে।
ম্যাম কত পার্সেন্ট চান্স আছে খোলার মোটামুটি?
কি করে জানবো রে, আমাকে তো খবর দেয়নি।
ম্যাম মানে 50-র উপরে ম্যাম?
তোমাদের করোনা ভাইরাস তো আমায় কোনো খবর দেয়নি। আমাকে একবার খবর দিয়েছিল 2 মাস আগে। আই ওয়াজ ডাউন উইথ করোনা। মানে 1 মাস ধরে আমি খুব অসুস্থ ছিলাম। তারপরে আর কোনো খবর দেয়নি কবে ও আবার আসবে না আসবে। তোমরা সেফ থাকো তাহলেই হবে, এটা খুব খারাপ অবস্থায় যাচ্ছে। বিশেষ করে তোমাদের মানে যারা ইঞ্জিনিয়ারিং এর, তারা কি করে কি করবে আমি জানি না। তোমাদের কিরকম ইয়ে হয়েছে ক্যাম্পাস রিক্রুটমেন্ট, জানো তোমাদের ডিপার্টমেন্টে লাস্ট ইয়ার?
আগের ইয়ারে তো 9.56 ছিল অ্যাভারেজ।
না না, তোমাদের আগের বছরে 4th ইয়ারে যারা হয়েছে তাদের কত পার্সেন্টেজ হয়েছে? মাইনে তো পরে দেখা যাবে। সবাই পেয়েছে তো চাকরি?
পার্সেন্টেজ বলতে ম্যাম?
চাকরি পেয়েছে?
রিক্রুটমেন্ট রেশিও
হ্যাঁ,
হ্যাঁ
অ্যাকচুয়ালি।
ম্যাম 86%।
তো বাকিদের,
পার্সেন্টেজ।
যাদবপুরের বাকিদের কি হবে? প্রাইভেট ইউনিভার্সিটি, প্রাইভেট কলেজগুলো বাদই দেয়, ওদের তো কিছুই হয় না। যাদবপুরে এই যে 14% বাকি রইলো, তাদের কি হবে?
ম্যাম তারা চাইলে অফ ক্যাম্পাস ট্রাই করতে পারে, বা অনেকজন হয় ম্যাম রিসার্চ করতে যায়, ওরা প্লেসমেন্টের জন্য বসে না, আর কিছু জন পায় না। তো যারা পায় না ওরা অন্য কোম্পানিতে ট্রাই করবে অফ
হ্যাঁ,
ক্যাম্পাস।
হ্যাঁ, অফ ক্যাম্পাস করবে, এই তো, সেই তো। যাই হোক, খুব খারাপ অবস্থায় যাচ্ছে। আর তোমাদের সবাই কি তোমাদের লাইনে কাজ করছো, কনস্ট্রাকশন, নাকি সব আইটিতে চলে যাচ্ছে?
ম্যাম কয়েকজন করে যাবে, কয়েকজন আইটি, ডিভাইডেড 50-50।
50-50 কনস্ট্রাকশনে, হ্যাঁ সেই, সেটাই। আর কিছু করার নেই আমাদের হাতে। ঠিক আছে, ভালো থেকো, সাবধানে থেকো। নেক্সট উইকে আবার কথা হবে, হ্যাঁ? ঠিক আছে।
ওকে ম্যাম, থ্যাংক ইউ।
থ্যাংক ইউ
থ্যাংক ইউ
ম্যাম।
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 থ্যাংক ইউ ম্যাম।
থ্যাংক ইউ।